Hello, welcome back to my channel. This is a little different video than what I usually post, but I had some time to play around with FreeCAD and decided to put together a little example of how I model stuff in FreeCAD so that when I 3D print the parts, they will fit correctly. And also a way to easily modify the tolerances of the part when I go to print it. So essentially what I do is I create a spreadsheet in FreeCAD, as you can see on the screen here. And within the spreadsheet, I set up my tolerances that I'm going to either expand my inside diameters or outside diameters or different dimensions by, and then I'll save those into the spreadsheet with aliases. And then within the actual application, when I'm creating the different shapes, I will add these dimensions to the actual numbers, the real life numbers, and that'll take into account the extruded portion of the print that goes over or under the normal dimensions for me automatically. So here we're going to jump right into creating a part. There's plenty of resources online on how to actually set up the spreadsheet, so I won't go into super detail about that. But I'll create a part using the sketch inside the part design workbench on the YZ axis, and eventually what I'm going to do is I'm going to revolve that sketch around the YZ axis. So here, when I create the part, it's going to be essentially a cutaway view straight down the center of the part, and it's going to have all the different layers that will eventually be revolved around into the different discs that will make up the whole part. So the dimensions, I'm not going to put in yet, I'm just going to do the general layout of the part, and then I'll use the constraints to set all of my dimensions up. So here at the very top, I'm going to set the radius of the part, and when I set this, if you notice I clicked a little formula bar on the right, and then when I go type in the value here, I'll type in my actual dimension that I measured on my original part, and then I will also add to that actual dimension. So here the actual dimension plus the spreadsheet, the name of the spreadsheet, in our case it's just spreadsheet, and then period, and then it will ask for the alias, or as you start to type in the alias, it'll automatically fill in the alias that's used for that particular dimension. So in my case this will be circle outside diameter, because this, when it revolves, will be an outside diameter. And then I hit OK, and now you'll see the actual dimension is just a little bit larger than 1 millimeter compared to the 2 that I originally had. Then another dimension, the next portion down, you'll see the same thing. I'm going to add the outside dimension as before using the spreadsheet. So 5.67 is my original measured dimension plus the spreadsheet outside diameter is actually divided by 2 because the value here is just the radius. So that's what I also did on the previous one. I took the original dimension, added the tolerance, and I divided it by 2 so that I had a radius dimension. And then I continue through the rest of the design doing the same type of dimensions. So once all the dimensions are set, you can see that the design is fully constrained because the entire thing is turned green. At this point, I can now revolve this sketch using the revolve tool. With the revolution, it's set for 360 degrees. I'll have to zoom out a little bit because I was in a previous workbench. The screen's a little bit mixed up here. Now we have the revolved part, as you can see on the main screen here on the top. There's a few other things I need to do to this revolved part. I need to cut some notches in the very top so that it can fit into the design that I'm trying to fit it into. So once I've selected the very top of the part, create a sketch on the very top part. I'm going to draw 2 boxes, and the 2 boxes are going to make up like a jig to cut out the portion of the circle or the cylinder that I don't want anymore in order to make it keyed to fit onto the device that's being fit onto. And just like before, when I set the tolerances in, I'm going to use the formula that's in the spreadsheet, or the value that's in the spreadsheet. In this case, it's going to be using the X value for the outside diameter of the box, so that it takes into account the squish on the 3D printed part. And really, the remaining dimensions, they don't matter that much, because they got to be larger than the diameter of the cylinder that I'm cutting. So as long as I make them larger than the diameter, they'll be okay for this process. Now you can see we have the fully constrained part here. I'll use the pocket tool in order to essentially extrude that parameter, or extrude that sketch down deep enough to pocket the portion that I don't want out of the image, or out of the 3D model. There's also a chamfer in the bottom of the portion here, so I'm going to select both sides, both lines, and I use the chamfer tool in order to bevel this edge, so I can set it at 1. If you set it too far, the chamfer tool, the whole model will disappear, or it'll fail to create the chamfer. So you got to play with the dimensions just a little bit to get it almost perfect. It'll be close enough since it's 3D printed anyways. Finally, the last part of the model is to put a hole in the very top that I'm going to end up putting a screw through. So I select the small hole that's up there now, create a sketch on that hole. And here I could select the center point of the sketch, create the hole. I'm going to set the diameter of the hole using the constraints. And then in this case, I also have to use the formula as before so that I can add my additional tolerance from the 3D printer onto this. So here I add the inside diameter tolerance, and I don't have to do divide by 2 because this is already a diameter constraint. So I save a little bit of time with that. Hit OK, and inside that, and something that I did notice when I did this was that diameter is actually larger than the original hole. So clearly I did something wrong on the original sketch. So I had to go back to the original sketch. And what I had done was I did not make the dimensions for the top long enough. So instead of 2, I set it to 4. And then when you update the sketch and close it, everything will automatically update. So in my case, that portion updated, but then it had also broke the chamfer that I had made previously. So first I thought it actually messed up the cut portion of it itself, but it was really the chamfer that got broken because the original circle had gotten moved off the top and somehow got moved down below. So I just had to go back and essentially delete some of the steps that I had done previously and then recreate the circle on the top in order to do the hole. Now we can see that the original, or the hole is the correct size now. It's actually within the end circle, so I just use the tool to punch a hole through. I don't use the hole tool, I actually use the regular tool to just go through, the pocket tool. So I use the hole tool, I have to set all the other dimensions for screw size and all that kind of stuff. I don't really want to deal with that, I just want to go into so many millimeters of the part. So because I intended to add another back portion onto this part that's going to be designed differently, I had also went ahead and put in a separate octagonal dimension that I was going to cut into the part to some portion, a few millimeters or so. So this way I can create different attachments and I can just glue them into the part. When done, it'll make a really solid surface. The reason for that is because whatever I attach to the face plate of this component, it's going to be hard to 3D print it correctly on a 3D printer without a bunch of additional material to hold up anywhere there might be spaces or gaps in the actual part. So here we just make the octagonal shape, use the pocket tool, bring it in a few millimeters, and then that'll have to be broken out once I 3D print the part, because I'm going to put this bottom piece that I'm working on right now on the build plate and 3D print it going up to the very tip at the top. So in order to 3D print the part, I have to select the body. So you see the whole body's green. I can go up to export and export it as an STL part, which you can see selected here. It's really important that you highlight the body that you want to export, and you can, accidentally export portions that are not the correct part that you're even working on, or export nothing at all if you don't select the body. So make sure you select the body, export it. So I actually use Ultimaker Cura for my slicer. So here I can import the part in. It's already the right position and everything. So I make sure all my settings are set for the PLA that I'm going to be using. Slice the part. It'll allow me to then save the part to the flash drive that I will put into the 3D printer. And that should get us going.